Our next speaker is Masaki Fujimoto. Masaki is the head of planetary efforts for the Japanese Space Agency, and we are working on a partnership between Survey and the Japanese Space Agency, primarily with Masaki. His talk is on the ISAS program for small body exploration. So, welcome.
Okay. So we are very much seriously interested in joining Survey because of the reason listed here. Well, at the level of the space agency, there's more and more need to have tighter connection between science and exploration. But at the Space Science Institute level, which is our institute, we are having two missions. One is a SLIM, mission by the name SLIM. It's a small lander to make a precise landing on the moon. And also MMX, which been mentioned already in the previous talk. So today I'd like to concentrate on the MMX mission, which is a mission to go to the moons of the Mars and then make a sample return from one of the moons. We wish it's Phobos, but we haven't officially decided yet, but I hope it's going to be a Phobos sample return mission. So why do we care about the Phobos sample return? There could be multiple reasons, but for us, it's related to the mechanism that enable the habitability of the solar system. We know about the habitable zone, but at the same time, we have to realize that the habitable zone is located inside the snow line, which means that rocky planets that are in the habitable zone must have been dry. And so there must have been water delivery from outside the snow line to enable the habitability at all of these planets. So realizing that the rocky planet must have been born dry leads to the question, how was water delivery to Mars? As a part of the big question, how was the habitability of the solar system was enabled at all? And the small bodies from outside the snow line would have played the role of the delivery capsule of water from outside the snow line. Mars is sitting at the outer edge of the habitable zone, and you must have witnessed the process of the water delivery. And Phobos could have been related to this delivery process. That's the background between our strategy of having this Phobos sample return mission. So the goal of our Phobos sample return mission, MMX, the objective is to review the origin of the Martian moons, which is not clear yet. But beyond that objective, we have the goal. The goal is to make a progress in understanding of the water delivery process, which between the border, across the border between the inner part of the solar system and the outer part of the solar system. So our goal is really to understand how the habitability of the solar system was enabled, the mechanism that enabled the habitability of the solar system. Now, about the origin of Phobos and Deimos, it's not known, as has been already mentioned. And then there are two leading ideas. One is the captured primordial asteroid, and the other is the giant impact. But and once you have the sample returned, we think knowing the origin is not easy, but still should be doable because of all the grant facility that's now available now, and that will be available in the next 10 years. And whichever idea finds to be the case, further information related to the behavior of Phobos creating small body that must have originated outside the snow line should be obtained. And that's the strategy of this mission. So that clearly tells you that there's a good synergy between our Hayabusa 2 mission and also NASA OSIRIS-REx mission, because these two asteroid missions are going after the reservoir question, while our MMX mission is going after the transport question. And indeed, Hayabusa 2 mission, the asteroid mission, and then this Phobos sample return mission, MMX, really constitute the backbone of our roadmap for small body exploration. And this poster kind of depicts our strategy. We have a series of missions going to the small bodies that must have born outside the snow line. And we are interested in those small bodies born outside the snow line because of the role it must have played in enabling the habitability of the solar system. So these small bodies were born outside the snow line. They evolved, and they somehow played a role in transporting water or volatiles to the rocky planets of the solar system. So I think it's we think it's worth of making a series of missions to make a systematic studies, systematic investigation of these small bodies, and that strategy is really depicted in this graphics here. So we have Habitability, we have MMX, and we also have another small mission by the name Destiny Plus. I can't help talking about this small mission here because I do recognize that dust science is a major element of this survey effort, and Destiny Plus mission is really tightly linked to that science theme. Destiny Plus mission is a small mission under planning to perform a flyby observation of the active asteroid of Phaethon, and then to make an in situ dust analysis during its interplanetary cruise. So I really hope to tell you more about the Destiny Plus next year, because Destiny Plus is now in the final stage of before the selection, and maybe next year I'll be happily telling you what science we can expect of this mission. But now back to MMX, Phobos sample return mission. What's the timeline? The launch is in 24, 1 year cruise to Mars, and then we get Mars orbit insertion, Martian system orbit insertion, and 3 years in the close proximity of Phobos, quasi-satellite orbit, and then departure from Mars system in 28, and then Phobos sample return in 29. 10-gram minimum, 100-gram target, and then sample from 10th meter subsurface is being expected. So here's the mission scenario. I'll just concentrate on the reddish part here. After insertion into the Martian system, we get into the quasi-satellite orbit around Phobos for close-up observations, and then we make a selection for the landing site, land on the surface of Phobos and make the sample collection. And then we transfer to Deimos flyby and make some flyby observation of Deimos, and then return to Earth. So quasi-satellite orbit around Phobos, and then landing and sampling on Phobos is the critical part of this mission. So we have to land on this surface, and then how do we land? How do we collect samples? This is what we are studying now. We really land on surface because the gravity is small, but still not too small that you can make a touch and go sampling scheme. So we really have to land on the surface for at least a few hours, and then deploy the manipulator, and then using the Cora system, we get the sample from the targeted spot. We make the monitoring on the surface, and then we design where to get the sample from, then you insert the Cora. And by using this system, we can get a sample from 10 centimeters subsurface. And then, I mentioned about landing, real landing. So that makes you worry about the safety, and how much do we know about the Phobos, about the property of the Phobos surface? And there's a study team led by Miyamoto-san at University of Tokyo, and what he is doing, what the study is doing now is that there are parameters that we know well enough of, but on the other hand, we don't know much about we don't have high resolution enough data about the surface. That's something you have to worry about, which we will obtain by our missions by ourselves, but that's something you have better worry about now. And at the same time, we don't know much about the mechanical properties of the surface of Phobos. So there are, there are numbers, but we don't think we know, and then we don't think we will ever know about this, but still, you better do the best you can so that you don't make any mistakes. And so what Miyamoto-san doing now is to make a simulant materials for surface, and then do some testing. That's what we mean by do as much as possible before we launch our mission. Unfortunately, in our country is full of geological diversity. So if you go around the small islands, you can collect a variety of rocks from which you can create the Phobos simulant. Maybe I'm not showing it here, but he has he wants to make a simulant for two extreme end members. One is for the captured scenario, and the other is for the giant impact scenario. But that's doable by using all the materials available within the country. So And that's what he has been doing. And then he makes a mixture and they press it with a careful control of porosity, and then crush it down so that you can have the angular, shapes which you would expect for a situation. So it's really this kind of effort we are already starting to develop, and then this is something we can expect survey community to help us. And I also mentioned about the landing site selections. There are some data already existing. So why not start a study now with the existing data? I think I can't agree with you more, but where's the expertise and the manpower? If you constrain ourselves to the resources available only within our country, I don't think we have enough expertise, but that's something maybe the survey member can help us. So there are at least 2 immediate and clear reasons for JAXA to be interested in joining the survey, and this is the message I want to send out today. Thank you very much.